this question, we look at using MacLaurin series to determine the power series of cosx to the first four terms. We then use this series to calculate the value of cos of 2 radians. So, as before, we used the MacLaurin series to create a power series for the function. And this time, the function fx is equal to cosx. So first we need to carry out a successive differentiation to give us the coefficients in this series. So the first derivative is found by differentiating cosx, and if you differentiate cosx, you get minus sin x. Differentiate sin x, we get cosx, but because there's a minus sign there, we leave this as minus cosx. Differentiate cosx again, we get minus sin x, and minus by minus will give us plus. So the third derivative becomes sin x. Differentiate sin x, we get cosx, and differentiate cosx, we get minus sin x. So you can see after the third derivative, the pattern starts to repeat itself. So now we substitute 0 in for x to give us the value of these functions for f0. So f of 0 is going to be the cos of 0, which is 1. The first derivative with x equal to 0 is going to be the minus sign of 0, which is 0. The second derivative becomes cos of 0, which is 1. Because of the minus sign, this becomes minus 1. Sine of 0 again is 0. Cos of 0 is 1. And minus sine of 0 is 0. So as I said, you can see the pattern repeats itself after the third derivative. So next we substitute these values of the derivatives in for the coefficients of the MacLaurin series. And that will give the following expression. Now you'll notice that I put x to the power of 6 over 6 factorial, because the sixth derivative is going to be minus 1, because it follows the same pattern as the second derivative. So anywhere we have 0, we put, or anywhere we multiply by 0, we put 0. So that will give the following expression. And if you use your calculator to work out the factorial terms, we get the expansion, or the power series for cos of x is 1 minus x squared over 2 plus x to the power of 4 over 24 minus x to the power of 6 over 720. In part 2, we are asked to determine the value of cos of 2 radians correct to 3 decimal places. So once again, we write the power series for cos x that we worked out in part 1, and anywhere we have x, we substitute 2. So if we use our calculator, this works out to be the following expression, which works out to be minus 0.422. And if you check the cos of 2 radians using your calculator, you find that you get the same answer. So here's a question that you could try. Use the MacLaurin series to show that the first 4 terms of the power series of sin x is given by the following expression, and hence calculate sine of 0.6 radians correct to 3 decimal places.